Okay, let's do a review of the exponential function. Draw the following two graphs, the f of x and the g of x, on the same set of axes and compare the two functions. Okay, f of x is 2 to the power of x and g of x is a half to the power of x. What I need you to see is, because this is an exponential graph, x is an exponent. So in order to do this, we're going to start, let's do the f of x in blue, and we can do the g of x in green. In order to sketch the graph, I don't have a y-intercept, right? Well, I do if I know anything about exponential graphs, but what I'm going to do is I'm going to do my xy table. So if I do an xy table for the f of x, I can start with -2, -1, 0, 1, and +2. If I go ahead and I do that, I'll start in the middle and I'll say, if x is 0, 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of -1 is going to be 2 minus 1, which is 2 minus 1, which is a half. Okay, and 2 to the power of -2 is going to be 1/4. Okay, so what I want you to see here is that this y value keeps going smaller and smaller in that direction. Once we reach 1, instead of going to 0, it goes to a half and then a quarter, and it keeps halving and halving and halving. So 4, half of 4 is 2, half of 2 is 1, half of 1 is a half of a half is a quarter, half of a quarter is an eighth, then a 16th, etc., etc., etc. But what I want you to realize by the statement I'm saying is that it will never reach 0. There's no number where you can say a half of an unknown number equals 0. That's impossible. Or half of 0, but we're never going to reach 0. This reality that we're just discussing here speaks of the asymptote. So this here is the asymptote of this graph. What does this asymptote mean? An asymptote is a point that the graph tends towards, or strives towards, or goes towards, or tries to attain, but it never ever touches it. So do you remember in the previous video we were talking about the domain and range, right? And there was one where we said that y in the curly bracket, and we said y was greater than or equal to 2, and y was an element of all real numbers. Now, this is not an asymptote because it touches it. But if 2 was an asymptote, then this section would not have an equal sign. It would be just greater than 2. If it was an asymptote, it goes towards it, but it never, ever, ever touches it. So at this point, we now have points that we can plot, and we also have a little bit of theory with regards to the asymptote. Okay, let's go ahead and plot this, and we're going to say, okay, we're starting with 0, x is 0, y is 1, 0, 1, and then 1, 2, and 2, 4, and then we have -1/2, and we have -2/4, and the important thing to see here is that your graph tends towards this x-axis, and this is super important when you sketch it. It must never touch. Please make sure that your graph goes to the end of the Cartesian plane. Do not cut your graph short. So this is our blue graph, VF of x. Okay. Let's go ahead and do the green graph, which is the same thing. Okay, so we're going to say the g of x is equal to 1/2 to the power of x. Okay, let's start with our xy table, and we're going to say -2, -1, 0, 1, and 2. Now we're starting with a fraction, so we expect the opposite. When x is 0, then y is 1. When x is 1, then we have a half, and when x is 2, we have a quarter. Minus a half, or minus 1 is going to give us positive 2, and then we have positive 4. Obviously, you can just use your calculator for that, right? So what I want you to see here, we can go ahead and plot this, and we can say, okay, 1, and then we have negative 1, 2, negative 2, 4. Okay, I want to go in the middle. Then we have a half here, and we have a quarter there. And these two are a reflection, if you can see, oopsie. At the end of the Cartesian, and over here, let's see what I can do over here, going up. Not so great, but okay. So the green graph is going to be the g of x. That's kind of important. We've got our asymptote here as well. What do you think the asymptote of these two are? Again, y will never ever equal 0. So over here, our asymptote on this graph is going to be the x-axis, or the line y equals 0. Y equals 0. That's what our line will never ever 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 be. It will never touch or cross over y equals 0. That's our asymptote. Now, the next thing that I want you to see is, notice that over here you have 0, 1, and over here you have 0, 1. I want to point out the fact that if you don't have anything added on at the back, right, if you just have the exponent, then it will always go through x is 0, y is 1, always, unless there's like a plus or minus, so that would be a translation. If there's a translation, it's different, but all of them will go through that. Okay, so if you're looking for your intercepts, notice you have 0 x-intercepts on the standard one, unless there's a translation. So what other thing they're asking us to do is to compare? Okay, let's go ahead and compare. Remember, this was not for this one, right? Okay, let's compare. What is the domain and what's the range? Both of these graphs have an asymptote. We have the asymptote on there. Anything under the asymptote, let's do it in blue because it's bigger. Anything under the asymptote is not part of the graph. So this tells me that these two lines have the same boundary, and that boundary is y equals 0. That is a lower boundary. So for both these graphs, I can say that the domain, I'm not talking about that, I'm talking about range. For both of these graphs, I can say the range is going to be y colon, y is greater than, not equal to 0, semicolon, y is an element of all real numbers. Wrong bracket. And for my domain, x is an element of all real numbers. This applies to both graphs. The other thing that they have in common is the x-intercept 0, 1. One is a reflection of the other, which is also interesting to see. The line of reflection would be the y-axis, or the line x equals 0. Okay, so that's your basic revision of your exponential function.